Today we are going to discuss about different acid-base concepts. First one is Arrhenius concepts of acid and base. According to Arrhenius concept, an acid is a substance which give H plus ion when dissolved in water. Similarly, a base is a substance which give OH minus ion when dissolved in water. So this Arrhenius concept is limited only in aqueous solution. So an acid is a substance which give H plus ions in water, and base is a substance which give OH minus ion in water. For example, if we consider HCl, HCl when dissolved in water, it get dissociate into H plus ions and Cl minus ions. We know that this H plus ions is surrounded by water molecule and become hydronium ion. So HCl when dissolved in water gives H plus ion. Therefore, HCl is an acid according to Arrhenius concept. Here we know hydrochloric acid is an acid. Similarly, nitric acid. Nitric acid when dissolved in water we get H plus ion. So it's an acid. Sulfuric acid when dissolved in water it gives 2 H plus ions. So we can call it as a dibasic acid. Similarly, phosphoric acid H3PO4 it contains 3 protons, right? And when dissolved in water, it get dissociated into 3H plus ions and phosphate ion. So we can call it as a tribasic acid, etc. And ethanoic acid, we know that it's a weak acid. Weak acid means it dissociates only partially in water, right? It gives H plus ions in water. That's why we call it as an acid. Similarly, carbonic acid. We know that when carbon dioxide dissolved in water, we get a soda or carbonic acid. It's also a weak acid. Now, consider potassium hydroxide. Potassium hydroxide, we know that it contains OH minus ion. When dissolved in water, we get K plus ions and OH minus ions. And both K plus ions and OH minus ions are solvated by water molecule. And here KOH gives OH minus ion when dissolved in water. Therefore, we can call it as a base. Similarly, if you consider sodium hydroxide, it contains OH minus ion. So, it gives OH minus ion in water. And if you take calcium hydroxide or barium hydroxide, strontium hydroxide or etc., all these compounds contain OH minus ions. And when they dissolve in water, we get OH minus ion in water. Therefore, all these substances are examples of base. So this is about Arrhenius concept. So in conclusion, about Arrhenius, according to Arrhenius concept, an acid is a substance which give H plus ion when dissolved in water, and base is a substance which gives OH minus ion when dissolved in water. Now move on to Bronsted-Lowry concept. Right now, according to Bronsted-Lowry concept, an acid is a substance which give a proton. Proton donors are said to be acid. And base is a substance which can accept a proton. So acid is a substance which can donate a proton. Base is a substance which can accept a proton. Consider this reaction. Here we can see ammonia and water molecule. And here water gives a proton to ammonia and it becomes ammonium ion and we get a hydroxide ion. And here water acts as a proton donor. So proton donors are said to be acid. So in this case, water is a proton donor, so it is Lewis acid. Whereas ammonia accepts a proton donated by this water molecule. So since ammonia accepts that proton, we can call ammonia as a base. So this is about the Bronsted-Lowry concept. So what is a Bronsted acid? A substance which can donate a proton. And what is a Bronsted base? A substance which can accept a proton. Now here we can see this reaction is already discussed. Now move on to this one, HCl. When react with water, we can see that HCl donate a proton to water molecule and we get hydronium ion and a chloride ion. And in this case, water accept the proton donated by this HCl molecule. So water acts as a base and HCl acts as an acid. So here water acts as an acid, here water acts as base. So a substance which can act as both a Bronsted acid and Bronsted base. So such substances are said to be amphoteric. So a substance that can act as Bronsted acid and base, then it can be called as an amphoteric substance. So here Water, in this case, act as an acid. Here it is act as a base. So water is an example of amphoteric substance. Now discuss the conjugate acid-base pair. Now what is conjugate acid and what is conjugate base? Now here look into the example. Ammonia react to the water, we get ammonium ion and OH minus ion. And here ammonia accept the H plus ion given by water molecule and become ammonium ion. This pair of molecule, that is ammonia and ammonium ion, and they differ only by a proton. Proton means H plus ion. So we can call this pair of molecule ammonia and ammonium ion as a conjugate acid base pair. Here conjugate acid is ammonium ion and ammonia is a conjugate base. Similarly, water, it donate a proton to ammonium molecule, so it is an acid and it get converted into OH minus ion. So water and OH minus ion, we can call it as conjugate acid base pair. Here acid is water and base is OH minus. So what are conjugate acid base pair? They are a pair of species that differ only by a proton. Proton difference. We can see this ammonia and ammonium ion. Here the difference is only by a proton. So such species are called Bronsted acid base pair. Now move on to the next acid base concept, that is Lewis acid base concept. According to Lewis concept, an acid is a substance that can accept a pair of electrons. So according to Lewis concept, an acid is an electron pair acceptor and a Lewis base is an electron pair donor. If a substance can donate a pair of electrons, then it is said to be Lewis base. For example, we consider this reaction. We know that ammonia is in ammonia and nitrogen is sp3 hybridized, and ammonia molecule contain a lone pair of electron, right? And this ammonia, this lone pair of electron, donate to this BF3 molecule. BF3 boron, it belongs to group 13, right? The octet is not complete. It's an electron deficient molecule. So this ammonia molecule donate its lone pair to BF3, and a covalent bond, or we can say it is a coordinate bond, right? A bond is formed between nitrogen and boron, right? And here ammonia donate its lone pair to BF3. So lone pair donors are said to be base. So here ammonia is a Lewis base. So Lewis bases are electron rich molecule that can donate their electron pair, and this BF3 is electron deficient. In that family, boron family, we have BCl3, BF3, aluminum chloride, etc. All these are electron deficient molecule. Electron deficient molecules are said to be Lewis acid. So these are the various acid base concepts. Thank you.